okay. I don't know what
It's
I'm
not
doing.
on.
It's not on. Oh, that would be why it's not responding to my commands. So I want to start, first of all, were there any questions in the investigation down through, up to the explain part? Okay, on the explain part, were there any questions? I don't want to. Okay, then let's talk about the elaborate. And were I to do this again, and next week when I do this, I'm going to add Play-Doh manipulatable mountains on your tables, okay? So I'm making notes for myself to things to do with this and not do. So that's something that I'm going to add.
So how would you make Play-Doh manipulable mountains? Would you use this and put the Play-Doh in it and then take it off?
I would just have a mass of Play-Doh on the table and just say, okay, make a mountain kind of like the one that we used in the box.
Okay.
So it's not everything has to be the same, just so they have a kind of mountain that resembles that.
Okay. And then are you going to make the Play-Doh or are you going to have the Play-Doh there already made?
Oh, I'm going to have the Play-Doh. But the Play-Doh Corporation or whoever does it the cheapest.
Okay.
And maybe that's, hey kids, I need Play-Doh.
That's what
Bring me some Play-Doh and
I got a
Kleenexes.
full 40 gallons of Play-Doh.
There you go.
Did you really?
Yeah.
That's
Nice.
awesome.
No, I mean, I had kids bringing in like 12 packs of Play-Doh. Because I told them, I'll give you a couple points of extra credit if you bring Play-Doh. And they're like, oh, okay.
Okay.
I'm trying to get, Alexis, I'm trying to get to the projector. Do you know which one it is?
Computer 1.
Okay, all right. And the elaborate part is a little bit more difficult conceptually because it is conceptual. It's pictorial to abstract, and so those Play-Doh models are going to provide one more concrete experience that they can actually manipulate to try to help them answer these questions. So let's look first at this map. Laura, yes,
I just want something to talk about making your Play-Doh. Like if you lay it flat and make it thick, like cut out the lines on this from the map and like stack your mountain.
Oh, you could absolutely do that, but that's a lot
I
of
like
Play-Doh.
that would be.
No, like you make like a thin layer, you cut out, maybe a plastic knife to cut out the lines, and then that's one skinny flat layer.
Use thread.
So,
Okay, and if you do something like that, I suggest you use a mountain that's, the lines are way farther.
yeah, but if you would have really
Yeah,
showed.
yeah.
GeoBlocks has an entire book for that you use cardboard or cardstock, and yeah, it's real simple. There's, I don't know, 15 different designs in the book, and it's GeoBlocks.
So on our map here, what do you see? What are we looking at?
Lines.
Yeah, contour lines, okay. So this is a two-dimensional representation of a three-dimensional space. So on this map, what I see, when I look at a topographic map, I find the highest point, first of all, so I can get my frame of reference. And I see that this elevation is 7,000 feet above sea level. I notice that my index interval is 1,000 feet because these dark lines are labeled here, and they go down, they decrease by 1,000 feet. Here at the bottom, I have my 1,000 foot interval, and then one more down below. Now, the contour interval is not listed, but I see if I count between my index intervals, There's 1, 2, 3, 4, and then my next index. So there's 5 contour lines, 5 interval lines between going from one index interval to the next, which tells me a change in elevation of 1,000 feet divided by 5 lines. My contour interval is 200 feet. So there's 200 feet between in elevation. There's 200 feet of elevations change from one line to the next. So I'm going to make a note of that real quick on my map.
Are you gonna show what, with the graphing or no? Just
I will
curious.
if you want me to.
Well, I have my example, but I know if you're in higher level math, it's pretty, I liked it, I was like, ooh.
Okay, yeah,
I
I'll
liked
look at
it.
that. Okay, so the first thing, we've identified our peak. This is the highest point. Here's the lowest point. Now, I see that my lines are not circular or smooth like they were when we did our knuckles and when we did our volcano. This looks a lot more complicated to me. So I'm going to imagine myself on top of this mountain. And when I look out around me from the top of this hill here, what am I going to see? Where,
I'm sorry.
if I'm standing here above my 7,000 feet in
And
elevation,
you're looking south?
and I'm looking out, yeah, I'm looking at my awesome ranch there. I see what?
Right here it's steep, but then it's kind of gradual, like it's more going flat. But then over here it's extremely steep with the ridges. Like
Okay.
it's shows indentions.
So let's look at this right here. So this is, I'm going down in elevation, but then my lines spread out a little bit. What is that gonna look like?
It's gonna look not as steep,
Not a drop.
Like a ledge, okay?
Yeah.
Like a ridge? So I'm gonna mark this area right here as like a ridge. What about this area right here? If I'm looking down south along this one, these lines from here to here is very far apart relative to the other lines. That tells me that that elevation change was very gradual. So this is this flattest slope that we have in this area. So I'm gonna circle this too because that tells me that's a ridge as well. So I can see here with this big flat open area, this ridge kind of comes out this way here. But I see that this is kind of a V shape now rather than a smooth curve. I also see V shapes in here too. There's a lot of V's in this map. How do I know whether if it's a ridge, a V with a ridge though? Because I see V's with the ridge here, but I see V's here that are not part of the ridge.
The lines are so close together, you got a steep drop.
big.
I can have a steep drop off of a ridge though.
Well,
By the way,
but it seems it's more like a part where it's weathered or whatever, and like a gouge on the
Okay.
side.
And what do those go down to? Here. So this is, you're saying this is very steep right here, right?
Yes.
Okay, so if I go downhill, if I'm a rock tumbling down that hill, what happens when I get here?
In the valley.
You're gonna,
Because if I keep going, I'm gonna start rolling uphill again. So what is
you're
this
gonna
right here?
follow, you're gonna follow that V.
Why am I gonna follow the V?
Well,
Or how?
you would keep going, kind of bounce around where the lines are the steepest.
Okay, so imagine that you're a drop of water up here on the top of this mountain. You know how in the augmented reality sandbox, he made it rain? Where did the water want to go? Down. Does the water, when you're on the highway, does the water follow the highway with you, or does the water go off of the highway?
Goes off.
The water takes, gravity pulls the water down the steepest slope, right? That's physics. It pulls down and it goes along the shortest path down. So what does the shortest path down look like on this map?
Down the valleys, where down the valleys,
But what about before you get to those valleys?
the
These ones.
V's that are pointing inward.
Yeah, but what if I'm sitting right here and I rain right there at that dot? Am I going to cruise this
So
way?
you're gonna go to
I'm gonna go off
You're
both
gonna go
sides.
down.
So depending on which side I fall on the ridge, say I fall on the east side of this ridge and I'm going to follow the steepest slope down the hill. So from here to the closest contour interval that I can find. So to there, closest, 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 closest. So I'm gonna come down here until, now, the closest one from there is here. And then here. This is the path that this water is going to take down. I've just mapped the path that that water is going to take down if it falls right there. Now, once it hits this V right there, you'll see that V is different than these V's up here. What's the difference in those V's? This one we said indicates a ridge. What do these other V's indicate?
Valley.
A valley. Yeah, so what is the difference between these two V's? If you're looking at a snapshot of this map, you don't know anything except you know that the highest elevation is 7,000, the lowest is down here. And you see V's, these V's, versus these V's. What's the difference between those two V's?
They might have it.
Okay, the valleys are pointing where?
Looking at
They're
it,
opening
They're
towards.
pointing toward the
high
high elevation.
Okay, yes, the valleys, the valleys point, the V points to the higher elevation. The ridges point towards the lower elevations.
Gotcha.
This is where that Play-Doh would come in handy, so you can carve out a valley into the side of your mountain, and then kids can get at eye level and trace that level, get their pencil and just trace the same elevation all around their Play-Doh. You know what I'm saying? Like the, dental floss through it or something, but if you get down at eye level and they can just go around that and trace the eye level, like if you were doing your knuckle, you could trace eye level, okay? So that's where that manipulatable Play-Doh would come in handy. So my grocery list just got a little bit longer.
On the round table, like when the
Uh-huh.
pottery, and it spins.
Like a lazy Susan?
Yeah, and then you
Yeah.
spin it and there's your line on it,
That's a good idea.
as you hold it in one spot.
Mm-hmm.
Words that my elves didn't know were plateau.
Okay.
I had to show them a picture of a plateau so they could go, oh, that's what it was, a well. They didn't know what a well was, they just, so we had to
Yeah.
create
So you can, and
some
I
words,
think, is
some
that over
pictures for
here?
them.
Yeah, so the vocabulary part that I added in here, these are some words that,
Points towards the.
some of them are review, some of them are new. So you may want to refresh and remember in 6th grade when you did this. Bring back, activate that prior knowledge.
I had to actually get pictures out and create it up. We just
Okay, so now that we're feeling a little bit better about reading a topographic map,
Upside down.
let's see about how weathering and erosion is going to affect this land. So in 7th grade, you did a lot of weathering and erosion and deposition. So in 8th grade now, we're gonna apply what we learned and see how it's going to affect the topography here. So we talked about the path of water, and in the explain section up above on number 6, I asked, what is the greatest agent of erosion? What is the one thing that causes most erosion to occur?
Water.
Water. Liquid water.
I was gonna say
Yes.
kids.
That's a
No, that's a lot, that's a
Yes, so wind, yes, plays a factor. Ice plays a factor. Water is the biggest one though. That's really the fundamental thing that we need to worry about. So if you look at this map, if you will mentally picture yourself as a drop of water in the path that you will take, that's the area that will be most affected by weathering or by erosion. And the way it's affected is, think about this, guys. If you are water and you're going through a valley, and more water is coming in and more water is coming in as you're traveling down the path, what's going to happen to the volume of water that's traveling through your valley? It increases. Okay, when the volume of water increases, what else increases as it's going through that valley? Well, the energy of that water. And so that kinetic energy is increasing and increasing, and it is pulling down whatever it can get to. Whatever's loose, it's taking with it. That's how Canyon Lake ended up with Canyon Lake Gorge, was the energy in that water eroded everything in its path away. So in this model here, in this topographic map, if we follow the path of the water, which areas are going to be most affected by erosion? The valleys. So let's imagine, just for grins, that we identify this area right here, this valley, as the area that's going to be most affected by weathering, by erosion. Okay? So we've identified that. Are we all cool with that so far? Okay. So when weathering and erosion happen, the water washes away all of the sediments that have collected, and it has changed the shape of that valley. What has it done to the valley? Steeper, like this way? Steeper and deeper. That's good. Steeper and deeper. So how are these lines going to shape? Carolyn said that this area is going to become steeper and deeper.
So they're gonna get closer and
Like
wider.
Like this?
Like this, they're getting closer together.
What do you mean?
They'll move farther towards the, okay.
It's gonna cut closer to the center of the
So they're gonna get closer together.
Yes, that's good. Yes, exactly. So what happens, and think, you just picture yourself walking,
cut closer to the
you're
center.
standing right here. This valley right here is going to get steeper and deeper. That means that these contour lines are going to move closer to my finger, and this valley is going to cut into this mountain because it's going to get steeper. So this 3,000-foot elevation line is actually going to move closer in. So those V's are going to become more pronounced. The bigger the V's, the sharper it is, yes, and the steeper and deeper that valley is. Okay? And again, this is one piece of a big puzzle, okay? So this is just one exposure that I would give to a map. I would get more and more. I would go to the USGS or whoever you can get and get topographic maps and have them all over the place. Have kids go around and identify the landforms on those maps. Have kids predict which areas, maybe put sticky notes or something on there. I think this area is going to change, and have them draw the new contour lines and predict how those maps are going to change over time. And if you want, then your new Play-Doh model, if you have time, make a topographic map of that Play-Doh in a box, and, like we talked about. And then go back after you make your valley, go back and make another one and compare the two maps. So it's just one more exposure, one more hands-on. Okay, on this back page now,
Ours, like, can you put your? No, the other one, the back page. Ours is kind of
Yeah.
does not look like
The
that.
boxes, the whiteboards are all correct.
oh,
Ours look like that.
oh, that's exciting.
Not really, it's
No.
kind of hard to read.
It was a puzzle. It absolutely is. Because y'all are the gifted and talented crew, and this is differentiation. Okay, so what do we see here? What do you see right there?
2 landforms, maybe 3, I guess? What would you call it, 2 or 3? Hills,
Two separate ones.
top left.
So is this piece right here, is that steeper or shallower than the rest of it?
Steeper.
Okay, so if I'm looking for a topographic map of this area, what might I look for?
Flatland in that area. Steepness right there.
Okay, so steepness, but what does steepness look like on a topographic map?
Very close
Close
together.
together.
Lines close together, and so my lines close together are gonna be on the left-hand side. So, no, I mean, those are lines close together, but those contour intervals,
How many landforms do you
they're
have?
so
This
close,
is mix
yes.
and match.
Here's one that are lines close together, and then there's something else going on here. What is this? The hill. Do you think that matches? Okay.
This one and this one, right?
What about this one?
A hill with a gentler slope on one side and a steeper slope on the right side.
Okay. So what is that contour line, what are those lines gonna look like for this hill? You said this one is a gentle slope, so what are the lines gonna look like?
On one side.
Oh, hold up a minute, my bad. Denise,
Yes,
what are the lines gonna look like on the left side of
They're
this hill?
going to be farther apart, and on the right side, they will be closer together.
Very nice. So which one of these mountains,
We picked the one right across them.
right across, isn't that handy? Perfect. Okay, I love it. Okay, Tim, this one is for you.
Who's Tim?
You.
This one, right?
Ish.
Yeah,
Okay.
Ish.
That's
So,
the-
but just because of the discussion you and Quentin had,
Mhm.
what about this?
They're not touching, but they're the contour lines are not touching, but they're very close together.
So this is what we would consider a cliff,
cliff.
but it is not a vertical face. It's just an extreme